The Chicago Field Museum contains different specimens of different birds that are collected over the past 100 years. So in 2020, researchers decided to analyze these specimens, and they found one thing. They analyzed over 100 of these bird specimens, and in every single species, the average size decreased over the century. They did the same experiment with Australian birds, and they found out that the birds in Australia also decreased in size over the past century. The bird size decreased by almost 2%, but the wingspan of these birds increased by almost 2%. It's not just birds that are changing size. Salamanders in the Appalachian, wood rats in the Mexico, and fish and other invertebrates in the Atlantic Ocean are also decreasing in size. But why are these happening? In order to understand why this happens, we need to understand something known as Allen's rule. So the main problems for animals living in the colder climate is obviously heat conservation. So if you decrease the surface area, then you can preserve more heat because surface area is what lets the heat escape. And for a given volume, the shape with the least surface area is the sphere. So in colder climates, animals get more spherical to conserve this heat. So animals living in the colder climate, like the snow leopard right behind me, have a more spherical body shape. They have shorter ears, shorter legs, and shorter arms, and they have a much fluffier and rounder body compared to other animals that are living in the tropical climate. And this rule is known as the Allen's rule. After the Allen's rule, another German botanist came and introduced the Bergmann's rule. The Bergmann's rule states that in colder climates, animals tend to be much bigger. Now, the logic behind Bergmann's rule is that when an animal is bigger, then it's able to preserve heat more easily. Think of it like this. One big ice cube melts slower than a lot of smaller ice cubes of the same volume. And using this logic, a bigger animal can preserve heat much better than smaller animals. And the converse is also true. Smaller animals can radiate heat and survive in a hot environment much better than bigger animals. And there are many examples of this phenomenon. The polar bears that are living near the North Pole are much bigger than the tropical bears that live near the equator. The Siberian tiger is the biggest subspecies of tiger, and they live near the snowy mountains of Russia. Another example of Bergmann's rule are the little penguins. The little penguins, which are found in comparatively warmer climates like the south of Australia, are smaller compared to emperor penguins, which lives in considerably colder climates like the Antarctica. If you take a look at this graph, you will see that the size of moose increases as you go up in latitude in the country of Sweden. This graph illustrates that the moose that lives in colder climates tend to be bigger on average. You can take a graph like this for humans too, but the relationship is not this much linear. And the reason is we humans migrate a lot, but you can still see some connection. The people that live in colder climates, like the Inuits and Eskimos, tend to be bigger and bulkier on average than people who live in tropical climates. Because of global warming, the average temperature of the world is increasing. And to combat this change, the animals are slowly decreasing. Tree shrews in Northern America have recorded a 20% reduction in their size, and Australian songbirds found in places like this in the Dandenong Ranges have recorded up to 19 to 15% reduction in size. But the wingspan of these birds are increasing to increase the surface area and release more heat. Now, all of this seems true for endothermic animals, animals which generate their own body heat. But what about exothermic animals, like frogs? Do they record a reduction in body size? Well, the answer is true, but for a different reason. The higher temperature allows tadpoles to turn into frogs much earlier. But the rate of growth of the frogs is not controlled by temperature, it's controlled by hormones. And because of this imbalance, tadpoles mature and turn into frogs much earlier than they should be. And the result is smaller size of frogs. And this change is documented in various frogs all over the world. The size of aquatic animals are also decreasing because as the oceans are getting hotter, it's more harder for these animals to get access to oxygen. Because as temperature rises, the dissolved oxygen in the water will get a tendency to resolve and go back to the atmosphere. So in order to keep up with the decrease in oxygen, the fishes are getting smaller to decrease their oxygen consumption. Now these changes, they might seem insignificant, But there are lots of consequences when an animal gets smaller. When an animal gets smaller, it may produce fewer offsprings or fewer eggs, and that will decrease the population of that animal. If a carnivore gets smaller, then it will become harder for that carnivore to catch its prey. And if the prey gets smaller, then the carnivore might have to catch a lot of the prey in order to fulfill its appetite. So just a tiny bit of difference in the size can throw off the precise balance of the ecosystem by a lot. This isn't the first time animals are getting smaller. Around 58 million years ago, there was a period known as Eocene thermal maximum. In this period, the temperature of the Earth rose by around 5 to 8 degrees. And if you take a look at the fossil record, you can see that the fossils decreased in size by approximately 30% in this time period. But the thing is, the temperature is increasing 10 times at the rate right now as it was back then. It's the rate that's alarming, not the increase in magnitude. Animals was able to adapt and evolve back then, and animals are trying to adapt right now. The thing is, will they be able to adapt in time? Thanks for watching.